Okay, so not really sure why my computer crashed, but my computer definitely crashed in the middle of me explaining that last problem. So you can see up here, I still have the work. That's a correct answer. I was just in the middle of explaining. I personally would reconvert the rational exponent into a radical, so I'd have square root of x cosine of x, and then personally, I would change all of this stuff into a fraction where I have sine of x in the numerator. I'd have 2 in the denominator, and this negative exponent puts it in the bottom, 2 root x. Again, do you have to do it that way? No, you don't have to really do anything as far as simplifying is concerned. I just happen to think that looks prettier, and pretty is a subjective term, so, whatevs. And you can see here's all the work again and again. And the secret to number 4, again, what you now need to know is this right here. The derivative of tangent of x is secant squared of x. That is now 3 rules that you have to know from this section. There's going to be a total of 6, and it probably won't surprise you what those 6 are. Harmonic motion. I attached a weight to a spring, stretched it 3 units beyond the resting position, and released it at time t equals 0. Calculate the velocity and acceleration of the weight at time t, given the position function below. So we got s of t. We got some sort of equilibrium point right here. We're having a spring with a weight attached to it. I just like to have some sort of visualization to it. So in order to calculate the velocity and acceleration of this spring, we start with our position. We should remember that our velocity function is equal to the derivative of position, s prime of t. So in this case, 3 is a constant multiple. We've got 3 cosine of t. Acceleration is equal to our velocity derivative. Constant multiple of 3. Derivative of cosine is negative sine of t, or negative 3 sine of t. There's our functions for position, velocity, and acceleration. That's it. And we can start analyzing that stuff, like knowing that s of t is equal to 3 sine of t. I remember how sine works, and at t equals 0, sine is 0. At pi, we're going to have another 0 for our sine. So it looks like the position is going to be at equilibrium at 0 units. Then it's going to bounce up. It's going to come back down, and at pi units of time, it's going to be at 0 again. It's going to drop down. It's going to bounce back up. At 2 pi units, it's going to be at 0 again. So it's going to do that oscillating, bouncing back and forth. Every multiple of pi, it's going to be at the 0. Next thing we can do, we can figure out what our velocity is. So the velocity we know is 3 cosine of t. Velocity starts off at its maximum and then just starts dropping down to its minimum. So we know that the velocity is going to be at its maximum at 0. And then its minimum, where it's moving backward, is going to be at pi units. And then at 2 pi units, it's going to be at its maximum again. So that oscillation back and forth again. Let's see here. Next problem. Good day. Oh, this isn't a problem. This is a joke. Man, good day, displacement. Good day to you, too. Hi there, velocity. I take issue with that one because it should just be the derivative of displacement. How are you doing, acceleration? I'm doing quite well, and yourself? It sure is a glorious day, isn't it? Whatever. See what the dog's calling him? Proper name. All right, so the remaining trig functions that we have for our derivatives are going to be the derivative of cotangent is negative cosecant squared of x. The derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. I'm going to give you guys like a huge hint. I don't have these memorized in this order. So I'm just going to shift this over to the side. really what I have memorized as far as getting these 6 functions down, I put them in this order. The derivative of sine of x, the derivative of tangent of x, and the derivative of secant of x. Those are the 3 that I have memorized, and then I put this into some sort of matrix in my head that allows me to memorize these a little bit better. Because I know the derivative of sine is equal to cosine. The derivative of tangent is equal to secant squared of x. And the derivative of secant is actually equal to secant x, tangent x. And there's proofs for all 3 of those. I know I showed you the proof for tangent of x. If you want to see the proofs for any of those other ones, stop by office hours and I can show you. What I put over here in the second column of my brain matrix here, I put the derivative of cosine, the derivative of cotangent of x, and the derivative of cosecant of x. The reason why I put it this way, because in my mind, sine of x is kind of like analogous to cosine of x. And when I take the derivative of cosine of x, the derivative is going to be analogous to the derivative of sine, except anything that starts with a co is negative. So this would be negative analogous to cosine is sine. The derivative of cotangent is analogous to the derivative of tangent, but it's negative, and instead of secant, it's cosecant. And same thing with the derivative of cosecant. The derivative of cosecant, since any of the cos are negative, it is negative as well. And just analogous stuff to secant x, tangent x. So cosecant x, cotangent x. And that's the order in which I memorize them. Any way you look at it, you're gonna have to memorize them. So the yellow box is actually in your book. If you want it, it's on page... Thought it was in your book, but apparently it's just split up. So yeah, this is how I memorize it, or you can look for that yellow box in my PDF of my notes. Next thing, there we go. Find the equation of the line's tangent to the curves below at x equals 3. Ew, gross. Because I see, for instance, I've got x equals 3, right? So I know x equals 3. If I plug it into x, well, that's going to be easy. But eventually, because I'm trying to find the line tangent to the curve x secant x at x equals 3, I'm going to have to, at some point, find f of 3. And f of 3 is going to be equal to 3 secant of 3. Since 3 does not show up on my unit circle, I know at some point I'm going to have to use this guy right here. Since I have to use this guy at some point, why don't I just use it right from the beginning? So what I'm going to do here, I'm going to put the original function into my calculator. Let's clear out some of the stuff that we used earlier today. Clear. Okay. All right. So I'm going to have to put in x secant x. I know I don't have a secant button on my calculator unless I have a TI Inspire. I've got x divided by reciprocal secant is cosine of x. All right, cool. If I want to find the value of 3 secant of 3, I'm just going to go second, go into my table, and find f of 3. F of 3 is negative 3.03. Let me see it a little bit better. So what I'm going to do here is I'm going to go second, quit. I'm going to go on the home screen. Alpha trace y1 of 3 is equal to negative 3.0303259998. Okay, cool. I don't feel like remembering all of those numbers. And if I did want to remember all those numbers, I'd get a better approximation, or I could go to the 3 decimal places and just get like an okay approximation. Instead of doing any of that stuff, what I'm going to do, I'm going to store this value as my A value. So now I hit the store alpha A, all of a sudden I have that stored in there. So I've got this is approximately 3.03, negative 3.030, and I'm just making a note that I'm storing that as my a value. Again, that's what f of 3 is. Next thing that I have to do, I need to find out what is the derivative of the function evaluated at x equals 3. Well, I don't really feel like digging out what the derivative of secant of x is. And I don't really feel like finding the derivative using the product rule here. So you know what I'm going to do? I'm going to cheat. This is legal cheating, by the way. Second window. Nope, not second window. My bad. Alpha window. And derive ddx of alpha trace y1 at x equals 3. And notice what I have typed in right here is identical to what I have written over here. All I have to do now is hit enter, and I can see that my derivative at that point is approximately, not equal to, I had some lag on my computer that made that an equal sign, is approximately negative 0.578. Right? Yeah, okay, cool. And I'm going to store that value as b. Store alpha b. Store alpha b. I must have hit enter twice there. And now I have that stored as b. So now what I can do, the equation of the tangent line is going to be y is equal to my m. In this case, I made my m my b value times the quantity of x minus my x value, 3, plus a. If I'm really worried about writing it down on paper, I would probably want to say y is approximately my b value was negative 0.578 times the quantity of x minus 3 plus negative 3.030, so minus 3.030. But I wrote it in this format on my paper so that now I can check myself. Again, whenever I write the equation of a tangent line, I like to check myself. So I'm going to write this in as alpha b times the quantity of x minus 3 plus alpha a. And then I check myself. Does it look like I have a tangent line at x equals 3? Man, this is going to take a while to graph. Oh, not too long. The next part's just a line. Is it going to do it? Oh, look at that. Isn't that beautiful? Right at the point of tangency. It looks like I have a tangent line right there. So I don't want to do all of these because they're all pretty much doing this exact same thing and cheat and use your calculator. So, you know, go play with your calculator, have some fun. All that good stuff. I said down. Find y, oh, gross. Find y double prime if y equals tangent of x. Find y double prime if y equals cosecant of x. Okay. All right. So doing 1, if y equals tangent of x, y prime is going to be equal to, and I just have this chart pulled up here. So derivative of tangent was secant squared of x. Right? So now to find y double prime, I need to find the derivative of secant squared of x. Oh, crap. You guys don't know what's called the chain rule yet. If you knew the chain rule, finding the derivative of this would be easy. But instead, what we have to look at here, secant squared means secant x times secant x. So now I actually have to use the product rule for this one. So to use the product rule, I'm going to do the left to right plus right to left. So the left secant x times the right derivative of secant of x is secant x tangent. x plus, that was left to right, now I got to do right to left. Right is secant. Left is secant, so de left is secant x tangent x. For those of you following along at home, these are exactly the same term. So all I have to do is 2 secant squared x tangent x. And now I'm done. We could do cosecant, but nah. Instead, there's your practice problems. You can start on those. We're going to go over them tomorrow in class, and see you